Rationalizing the denominator or the numerator. If a fraction has a denominator of the form a plus b times the square root of c, we can rationalize the denominator by multiplying numerator and denominator by the conjugate radical. Remember, the conjugate is the same expression, except the sign is different. This works by special product formula that we learned about, that if we have a sum times a difference, right? We're going to, the middle terms will drop out, and you can see we'd have a times b times the square root of c, and we'd have negative a times b times the square root of c. These middle products here would drop out, leaving just the first term squared and the second term squared. And of course, if you square a square root, square and square root cancels. It's just what's inside. All right, so now let's take a look at this one. All right, and so long as you multiply the numerator and denominator by the same thing, that's just like multiplying by 1. You've changed the form, but not the value. So we're going to multiply, so our conjugate is going to be 1 minus the square root of 2. All right, so we're going to multiply the numerator by 1 minus the square root of 2. And we're going to multiply the denominator by 1 minus the square root of 2. Of course, 1 times 1 minus the square root of 2 is just going to be 1 minus the square root of 2. So we have a radical in the numerator, but we're going to get rid of the radical in the denominator. All right, so we know the middle terms are going to drop out, so we're just going to have the first one squared minus, because this is the difference of squares, right? When we multiply something plus something, and the same something minus the same something, right? So the first terms are the same, the second terms are the same, they're conjugates of one another, and the only thing that's different is the sign, right? We're going to have the first one squared minus the second one squared. All right, and so then we're going to have 1 squared minus the square root of 2 squared. All right, and now we can just simplify. 1 minus the square root of 2, and that's going to be 1 minus square root of 2 squared is just 2. And we're done. We're almost done, because we can combine those terms. Let's simplify that. So now we have, I'll go this way, 1 minus the square root of 2 divided by negative 1, which is just, so now we're just going to change the signs of each of those terms. We'll have negative 1 plus the square root of 2. Right, we just divided both of those terms by negative 1. Now we're done with the first one. Let's look at the second one. So now we're going to rationalize the numerator. Right? There may be times where we want the numerator rationalized, as you'll see later on in calculus. All right, so here our conjugate, we just changed the signs. So this is going to be, we changed the sign on the second one, right? We changed this operation sign is going to be 4 plus h plus 2. So we're going to multiply the numerator. Let me just write it down. 4 plus h minus 2 divided by h. We're going to multiply the numerator by the square root, of 4 plus h plus 2. And we're going to multiply the denominator by the square root of 4 plus h plus 2. All right, in the numerator, we're going to have, right, so the middle terms would drop out. You can see they'd be opposites of one another. So we'll have the first one squared. So we'll have 4 plus, the square root of 4 plus h squared minus the second one squared. In the denominator, we'd have h times the square root of 4 plus h plus 2. All right, so now let's continue simplifying, and I'm actually going to move this up just a tad. I am afraid I'm going to run out of space. All right, so we're going, the square and square root will cancel. This will be 4 plus h minus 2 squared would be 4. And you see we're going to be able to simplify again. All right, and the denominator we have h times the square root of 4 plus h plus 2. All right, so 4 minus 4, that's just going to be h over h times the square root of 4 plus h plus 2. And guess what? We're going to be able to reduce this, right? Because we can cancel out those h's. Those are just factors, right? Because we have h times, in the denominator we have h times the square root of 4 plus h plus 2. So the h's will cancel, and our final answer is just going to be 1 divided by the square root of 4 plus h plus 2. And we're done. So now we've rationalized the numerator. And you'll see where this will come in play next year. All right, so one last thing before we go. Let's look at avoiding common errors. All right, so don't make the mistake of applying properties of multiplication to the operation of addition. And subtraction is just addition, but we're adding the opposite. Many of the common errors in algebra involve doing just that. And remember, you'll make Miss Mashagna cry if you apply the properties of multiplication to the properties of addition. The following table states several properties of multiplication and illustrates the error in applying them to addition. So a times b squared is indeed, and I'm right here. Actually, let's give myself a handy dandy arrow so I can point. So a times b all squared is indeed a squared plus b squared. Excuse me, a squared times b squared. A plus b squared is not a squared plus b squared, right? So if you have a sum squared, it is not the sum of the individual terms squared. What it is a squared plus 2ab plus b squared, right? So actually, in your notes, underneath it, write that in so you don't forget that that's what it really is, not a squared plus b squared. The square root of a times b is indeed the square root of a times the square root of b, assuming that neither one of these is negative, right? Because then it would be we would be dealing with something else, right? We would be dealing with imaginary numbers. We can simplify them with their imaginary numbers, and we're in this case only dealing with real numbers. You cannot, however, split up a sum, all right? And we can see that if we were to take some, just take numbers, and you can see it wouldn't work out. All right, so for instance, let's take the square root of 9 plus 16. All right, so the square root of 9 plus 16 would be the square root of 25, which is 5. It is not, however, the square root of 9 plus the square root of 16, which would be 3 plus 4, which would be 7, right? Does not equal 7, right? So 5 and 7, not the same. Actually, I guess I should put equals over here, because that would equal 7. But 5 does not equal 7. All right, let's look at the next one here. If we have the square root of a squared times b squared, right? Square and square root would cancel on those, because this would be the same as the square root of ab all squared, right? So that would cancel. However, it's not the same if you have perfect squares added. All right, that is not true, right? And we can see that that's not true if we take 3 squared plus 4 squared, right? We know that 3 squared plus 4 squared is equal to 9 plus 16. That would be equal to, actually, I'll write the 9 plus 16 in, which would be equal to the square root of 25, which is 5. And that does not equal the square root of 3, excuse me, the square root of 3 squared plus the square root of 4 squared, right? The square root of 3 squared would be 3. The square root of 4 squared would be 4, which equals 7. And 5 does not equal 7. There's one more time. 5 does not equal 7. And you can use different numbers. I just happen to use those numbers. If we have a product, right, we can, and we're multiplying two fractions. We multiply the numerators, we multiply the denominators. That is true. However, 1a plus 1b is not 1 over a plus b. We need like denominators to add. It would be equal to, because I'd have to multiply this one by b and this one by a, right? Numerator and denominator in the first fraction by b, numerator and denominator in the second fraction by a, and then this would equal a plus b over ab. Right? But a plus b over ab is not 1 over a plus b, right? We can cancel factors that are, we can cancel factors in a product, right? We have an a in the numerator, an a in the denominator. The terms in the numerator are multiplied. We can cancel the a's and it would equal b. You can cancel factors. You cannot cancel add-ins, things that are added together. All right, and you can show that with any number. All right, let's make a it's a different number, 6, and b 7. Right? So if we had 6 plus 7 over 6, that's 13/6, right? It's not equal to 7/6. Guess I'm too close to that side there. All right, so you can see that that's not true. Right? You can't just cancel add-ins. Right? And if you've got a product raised to the same power, you can make that one product raised to 1 power, but not if they're added, right? That doesn't work, because what you're doing is you're undistributing essentially an exponent. You can't distribute an exponent or undistribute an exponent to a sum or difference. And we can use any number. Let's have a be 2 this time and b be 9. All right, so this would be 1/2, right, because we're raised to the negative power, and 1/9. We need a common denominator there, so in this case, this one needs a 9 over 9. This one needs a 2 over 2. All right, so now 18s are a common denominator, so that would be 9 plus 2. That's 11/18. What it is not is 2 plus 9 to the negative 1 power, which would be 1 over 11. Right? 11/18 does not equal 1 over 11. All right? So you can see that these properties that work for multiplication cannot be applied to addition. Right? So properties of multiplication are different than the properties of addition. All right, thanks for watching. Bye for now.